Hi everybody, Mrs. Reynolds here. I am going to go over a little foldable activity which is going to help you out when you are converting decimals to binary and from binary to decimal. This will help you for your AP exam too, because there are at least 2 questions on the AP exam requiring you to either convert binary to decimal or decimal to binary. So let's get started. The first step is you're going to take a regular sheet of paper, and I like to make, when I fold it in half, I like to make one side a different color. So I've made one side yellow and one side white, and feel free to pause this video whenever you'd like to catch up. So if I take my paper, I'm just going to fold it. I used to call this hot dog style, but you can call it horizontal, a horizontal fold. And if you notice, one side is yellow and one side is white. Again, you don't have to do this, but I like to separate my colors a little bit. So the next step is you're going to fold this in half like this. Okay, fold it in half again. And then fold it in half one more time until you get a little rectangle like this. Then when you open up your foldable here, you are going to have 1, 2, 3, 4, 5, 6, 7, 8 rectangles to represent 8 bits. Okay, so now we're going to get our scissors. We're going to open up our little foldable here, and what I'm going to do is I'm going to cut the yellow side on the lines, but only until I get to the center of the foldable, okay? So when you're finished, you will have the cuts that look like this. So you'll have this will be intact up top, and this will look like, kind of like a fringe on the bottom. Okay, so I've done this with my yellow version here. So we have the top is white and the bottom like a little fringe. And since binary is represented by 1s and 0s, we are going to label all of our top fringes here. When you close the paper, all of your top fringes are going to get 0s on them. So you have a 0 on each rectangle. When you open up the foldable, you are going to have 1s on each bottom rectangle. So here's a 1, different lighting over here. So you have 1, there we go, that's better lighting. 1, 1, 1, all 1s on the bottom. Okay, so now that the top of our foldable has all 0s and the flip side of our foldable has all 1s, we are going to label our little slats over here. So I know that this might be backwards if you're looking at it from home, obviously, but if you're looking at your foldable, so your foldable is right in front of your face, on your left, the tab on your left, you're going to put a 128 in that tab on your left, and that is 2 to the 7th power, okay? And pause the video, feel free to pause at any time. The next tab is going to have a 64. That is 2 to the 6th power. The third tab from your left is going to have a 32. That's 2 to the 5th power. The next tab is going to have a 16. That's 2 to the 4th power. The next tab is going to have an 8. That's 2 to the 3rd power. The next tab is going to have a 4. That's 2 to the second power. The next tab is going to have a 2. That's 2 to the first power. And your final tab, which is all the way on your right-hand side, is going to have a 1. And that's 2 to the 0 power. So now that we've set up our foldable, let's jump into some binary conversions. The first binary number we are going to convert is 110. So the question will look something like this on your AP exam. What is the binary number 110 in decimal form? So we're converting binary to decimal. Okay, so we want 110. We'll take our little foldable. Now remember, 110, okay? So we have to make the number on the right-hand side. So we're going to make 1, 1, and then leave 0 where it is. All of these zeros in the beginning, just ignore, okay? Because the binary number that we want is 110. So everything in front of that is still 0. So we're just going to ignore it. So here's our number right here. We were looking for the binary number 110 in decimal form. You ready for the decimal? Here it is, 4, 5, 6. So the binary 110 in decimal form is 6. Awesome, right? Okay, let's do one that's a little tougher. Here's the binary number 10101. Let's get our little foldable out. One, 0, 1, 0, 1. Here it is. 10101. Now let's figure out the decimal. Just look up top at the ones you've pulled up. We have 16 plus 4 plus 1 is 21. So the binary number 10101 in decimal form is 21. Cool, right? Okay, now it's your turn to use your foldable. Here's your next challenge. The binary number 10011. Go ahead and try and figure that out. Okay, so I asked you for the decimal for the binary number 10011. You should have gotten 16, 17, 18, 19. So the answer is 19 in decimal form. Okay, last one. 1001101 in decimal form. Good luck. Oh, this is getting hard to hold now. Okay, here we go. 1001101 is 153. Congrats if you got it right. If you got it wrong, work with your foldable. Okay, we're back to now convert decimals to binary. So the opposite, okay? So the first decimal we're going to look at is 6. So I'm going to have to make 6 with these top numbers here. Okay, so I've pulled up these 3, 4, 5, 6, 7. Oh, I got to put this number 1 down. All I want is 6. I'm trying to find the binary number for the decimal 6. That's 4 plus 2. All right, there you go. Look on the bottom. So the binary number for the decimal 6 is 110. 110. That's the binary number for the decimal 6. Okay, let's try and find the binary number for the decimal 21. So we're going to pull up the 16. We're going to not have the 8. That's too much. So we're looking for 21. So 16 plus 4 is 20. We don't need the 2. And then there's the 1. So you have 16, 21. So the binary number for the decimal 21 is 10101. Okay, now it's your turn to try it out. What is the binary number for the decimal 153? Okay, the binary number for the decimal 153, since I can't maneuver my foldable, I'll just show you over here. It's 100110001. Congratulations if you got this correct. If you didn't, just keep trying. You'll get it eventually.